Welcome to solverfy.
Hi, in the given problem there is an ammeter whose internal resistance is given as Ri, which represents internal resistance of ammeter. Now, in order to increase its range means the current which it can measure, a shunt resistance is joined in its parallel, having a symbol of R shunt. Now, it is given that the current which can be measured by this ammeter originally means without any extra shunt resistance in its parallel, that current is I. And now, as we want to increase its range n times, so after putting the shunt resistance in its parallel, its maximum range becomes Ni. So, if this is the current which will be measured by this ammeter Ni, this is the current which is required for the full scale deflection in the ammeter. So, the remaining current passing through this shunt resistance will be Ni minus I, using Kirchhoff's junction rule. Hence, as we know, the potential remains the same in parallel, means the potential drop taking place across this ammeter should be equal to that taking place across the shunt resistance. So, using Ohm's law, we can say potential drop taking place across ammeter means I into RIA is equal to Ni minus I, that is the current passing through the shunt resistance multiplied by the shunt resistance, which becomes the potential drop taking place across the shunt resistance. And it can also be written as, taking this I as a common out, N minus 1 into resistance of shunt. So, finally, the expression for the shunt resistance comes out to be I times of RIA divided by I times of N minus 1. Then cancelling this I. Finally, expression for the shunt resistance comes out to be RIA divided by N minus 1, which is one of the answer for this given problem. Now, in the second part of this problem, the value of the internal resistance of this ammeter is given as 1.00 ohm. Its range should be increased by 100 times because it is given that after putting the shunt resistance, the maximum range of the current which can be measured by this ammeter is 100 ampere, means it is 100. And the initial current which it can measure means the current required for the full scale deflection is given as 1.00 ampere. So, putting this value in the expression for the shunt resistance, the value of the shunt resistance comes out to be 1.00 ohm for internal resistance of the ammeter divided by 100 minus 1, means this is 1.00 divided by 99 ohm, or it comes out to be 0.0101 ohm, or finally we can say shunt resistance required to be put in parallel with this ammeter is 10.1 milli ohm, which is another answer for the given problem. Now we have to find the fraction of the current passing through the ammeter and that passing through the shunt resistance, as the total current is 100 ampere and that passing through the ammeter is 1 ampere. So easily we can say this fraction of total current which is passing through the ammeter is the current passing through the ammeter divided by the total range, means the total current which will pass into this ammeter, which is 100 ampere. So this fraction here comes out to be 1 by 100. So the fraction passing through the shunt resistance, it will come out to be 1 minus 1 by 100, means this is 99 by 100, means these two fractions are 1 by 100 through ammeter and 99 by 100 through shunt. So this is the last answer for this given problem. Thank you.